you for being here. And I just want to start with this. In the newspaper today, the Sunday Times, there's an article saying computer science graduates earn 5 times more than art students. The fact that they're in the top spot. And here's the article in the Sunday Times here with the Imperial graduates topping the list. So if you want to look at it, you can look at it afterwards. Okay. So, the title of the talk is The Secret Arts of Teaching Coding Successfully to the Next Generation. So I'd like to tell you a story, and the story's been told in the spirit of being helpful, of being able to try and make a contribution to the advancement of the teaching of computer science to the next generation. And we want to develop a successful working approach for the teaching of computer science or programming to the next generation. We want to ensure it's in a manner which is fit for purpose and which has the blessing of the educational community and the parents and the children alike and all the stakeholders. And most importantly, we want it to empower and allow the next generation to take a leading role on the world stage, confidently, successfully, and also competently. And I believe this is very much in our interests, as well as individually, as well as society. So the story is, having joyfully accepted the position of teaching computer science in a UK secondary private school in the UK, now after my initial euphoria had subsided, I began to think of the challenges with a great deal of trepidation. And these challenges would be quite heavy. The challenge was that I would be acting as a one-person band, single-handedly teaching all year groups from year 7, who are aged 11 and 12, to year 13, that are aged 18. And there are 110 students in all. I would be teaching a newly introduced subject, not only in this particular school, but it's quite newly introduced in the country and to the world as a whole. A few people had resigned before starting the post, and I was under no illusion that the task would be arduous, frustrating, backbreaking, and probably more often political in nature. However, I am of the belief that the task is quite important, and these problems are important, they're important to solve, and they are not insurmountable. Now, the challenges of teaching the subject are well acknowledged worldwide. So The Economist has written, the subject is so young that teachers and curriculum designers have little pedagogical research to guide them. Indian-born CEO of the global giant Microsoft, Satya Nadella, he recently said in an interview, the fact that most curricula in schools still don't recognise computer science like they do maths or physics is just crazy. Now, as I said, we should not think of these challenges as insurmountable. We are, after all, dealing with computers and technology, and these are the most positively disruptive force in the world. And they're completely overturning centuries-old ideas and approaches of problems in business, science, arts, and replacing them with innovative, more successful methods. So we can actually think of the teaching of computer science in the same way as another positive, disruptive, innovative technology, and approach the venture in the spirit of an entrepreneur with the sort of mindset of freedom and independence, and welcome it, just as our sort of heroes, modern-day heroes of Bill Gates, Steve Jobs, Elon Musk. So an entrepreneur, he requires, or she requires, or it requires, a vision, a mission, and objectives, unique selling points, or USPs, taking into account the stakeholders of the educators, parents and children, a methodology or approach, and an outcome. So let us look at the vision of what vision. Now, we are probably all acutely aware of the chaos and calamity that ensue with a lack of vision. So we should definitely adopt a vision. We should adopt a vision as an educator, and we should adopt a vision that we can transmit to the next generation. And we need one which everyone can actually buy into it. And I believe that we're quite privileged in that we can, in this subject, formulate quite a lofty vision that many other subjects cannot do. So the vision, and I've taken this from what I hear young children say in the playground, from their very conversations, is to create the world-class technologists to take a leading global position in the near future and to create a new next generation of Bill Gates, Steve Jobs and Elon Musk. Children are always talking about this in the playground amongst themselves, believe it or not. So the unique selling points are sales and marketing strategy. We have to take note that the subject of computer science or computer programming is competing against other disciplines which have a longer tradition, such as maths, history, Latin. And we also need to be aware of the fact that there are a number of different stakeholders, as I said, the educators, the parents, the children. So the key element is we need to formulate USPs that take into account all of these different groups. So the first USP is that computers are ubiquitous and prevalent in most, if not all, sectors of our modern day society. The applications involved: weather forecasting, robotic surgery, space exploration, e-commerce, scientific research, driverless cars, etc., etc. And it is, computer science and programming is regarded as one of the leading disciplines in the 21st century in actually many nations of the world. So, and if computers had not been invented, some say science would have actually ground to a complete halt, or almost to a halt, in the second half of the 20th century. So as a consequence of this, computer programming is now regarded as an essential skill for any ambitious, aspiring, self-respecting young person in any self-respecting nation, and it has been dubbed the fourth R, along with reading, writing, arithmetic, and now we have computer programming. So, in recognition of this new status and significance, governments worldwide have launched initiatives to have it taught in school right from the start, from kindergarten through to junior school to secondary school. And these are the areas in red, and we can see that they are in all continents, in Australia, America, Asia, Europe. And this is quite appealing to the educators, this USP. So the second main USP is the dominance, or the dominance of technology in the world economy. Now, the market value of the FANG stocks, Facebook, Amazon, Apple, Netflix, Google, is bigger than the economy of some countries. If it was a nation, it would be the fifth richest nation in the world. This is a USP which is very appealing to parents and guardians who are relieved to hear that if their offspring should be taking this new subject, as they see it, then decent organisations will be eagerly waiting for their offspring's services to offer them lucrative and stimulating careers, so their children will not be starving on the breadline. And the third USP is that the financial rewards for studying computer programming can be enormous. Now, it should be noted, of the top 100 richest people in the world, a substantial proportion of them are involved with computers. That is 20% of the world's billionaires in technology. That's 1 in 5 of the billionaires. And if we look at the top 10, that proportion increases substantially to 40%. So here we have Jeff Bezos in the number 1 spot of Amazon, Bill Gates, number 2 spot of Microsoft, number 5 spot Mark Zuckerberg of Facebook, number 10 spot we have Larry Ellison. And this is really very appealing to our young people. So, methodology. Just on the sideline, I also started a computer-assisted investment club, and lots of people joined. I think it was for the computer-assisted part, not the money, but we should discuss that later. So, methodology and approach. So, the national curriculum. Most nations, all nations in the world, have a national curriculum. In the UK, we have a national curriculum for every subject. It's a document detailing what we should be taught for each subject, and computer science is no exception. So after reading and rereading the document and a great deal of soul searching, it was decided that the UK national curriculum, although it's laudable in its intentions and it has very few design and process faults, it would be used as one of a number of guides and not be taken as a definitive authority on teaching the subject in schools. Now, resources and textbooks. A decision was made to equip all students with a textbook and exercise book, as note was taken of the fact that any subject which is taken seriously by parents and their children has an associated textbook and exercise book. Now, unfortunately, appropriate textbooks are available for the year groups 10 to 13, which is aged 15 to 18, but no appropriate reading textbooks. I don't think anything exists for years 7 to 9. That's 11 to 14. So therefore, worksheets, website, YouTube videos were all constructed to develop the resource space used by the students. And I have constructed a website and a YouTube channel entitled Lil Anonymous, which currently contains more than 60 videos for people who want to learn about computer science and computer programming. And the children seem to be watching them. Okay, so how should we start teaching specifics of computer programming? Particularly, let's take a worked example of, say, Year 7 students, those aged 12, those very much at the start of their secondary school career. You know, what language should we teach them? What type of language? Should it be drag and drop, or should it be something else? Now, in order to elicit or try and find some answers to these questions, a study was made of what the young students learn in other subjects at this age. A note was taken of the fact that at this age, it's not unusual for students in maths to solve simultaneous equations. In English, to read poetry, such as Rudyard Kipling's If, in English literature, to read A Midsummer Night's Dream by William Shakespeare. In geography, I have seen they have been asked to write essays on geopolitical events, such as what are the advantages and disadvantages of Brexit, and they write this with great gusto. So therefore, we can surmise that young people of this age, they are comfortable with being able to manipulate symbols, comfortable with sophisticated text and analyse them, so therefore concluded they should be able to cope well with a textual programming language, such as Python, as their first programming language. Now, Python, a decision was made to teach a computer programming language which is in demand by the employers of today. And of the dozen choices, Python was decided upon because it's the #1 teaching language worldwide in universities and schools. It's the #1 commercial language, I understand, used by the likes of Google, and it has seemed to have some good infrastructure and support mechanisms as well. I have to say, parents were tremendously grateful when I switched them all over to Python. They were using some obsolete language which I will not mention before. So, an endorsement for Python here. The Economist, a recent article in The Economist, said there are more searches for Python or the searches for Python is going up at a tremendous rate. That's in red there. So you could safely say there's more growing interest in this programming language than any other. But perhaps the most glowing endorsement of all is that the number of Google searches of Python outstrip those for international model, reality star and businesswoman Kim Kershiden. So that's probably the best endorsement of all. So, teaching approach. Now, a decision was made for a bottom-up approach to teach computer programming as opposed to a top-down approach. We'll describe that in a bit. The justification of the bottom-up approach is that it is a tried and tested method for teaching computer programming and quite traditional, albeit to adults. And foreign languages and mathematics are also being taught very successfully in this manner traditionally. So a bottom-up approach is when concepts and ideas they learn first and then they're used to solve problems. And top-down approach here is when a student is presented with a problem and he or she has to work out how to solve it. Now there's some trepidation as whether these are UK students would be accepting of this bottom-up approach, as the modern trend in the UK schools is to employ a top-down approach in most subjects. And it was felt that in order for the bottom-up approach to work, we would need some explicit buy-in from the students, as they are relatively unaccustomed to it. Therefore, we need to provide them with an explanation of why and what this approach is prior to any teaching. So the explanation began with the fact that computer programming languages can be thought of as analogous to human languages. We talk to each other in English, French, Chinese, Polish, and we talk to the computer in different programming languages, of which there are many, but we will be using Python. And they can think of an essay as being analogous to a program. And that essay is divided into paragraphs. A paragraph can be analogous to a function. A paragraph is divided into sentences. Sentences are analogous to statements, and sentences are divided into words, then which are analogous to keywords. So what we would be doing is that we would be learning about a keyword at a time, about its definition, how it's used in a program, doing lots of worked examples, and we would build up slowly to build very cool programs. Perhaps we could write a program about the driverless car in due course. And students appeared to like this explanation, and they bought into the bottom-up approach. And from time to time I was asked, are you fluent in Python? And parents at Parents' Evening mentioned how much their children were enjoying and loving the subject. So what is the... So this bottom-up, teacher-led approach to teach computer programming, it appealed tremendously to the younger generation of students and their parents. And the idea is that the basics are strong, and the school children can become confident, happy, and again, competent to tackle any given programming problem. So it's teaching by strengthening the fundamentals. So let's look at some outcomes here. We have some programs there, which are on the whiteboard by Year 7 children. Program 1 for J in range 1 to 11, print J, printing the first 10 numbers. The children did grasp the concept of a loop very quickly indeed. They liked it as well. We also introduced to them the fact that looping is iteration, for loop is an example of definite iteration. So as well as introducing the program, the terminology and the glossary behind it as well. Program 2 for J in range 1 to 110, 2, print J, printing the first 50 odd numbers, and again, they thought it was extremely cool to be able to do this. I'm sure I've seen the for loop being labelled, oh gosh, so only 5 minutes? Oh, as a advanced concept as well. just very quickly, they were taught the concept of subroutines here. They were given the first one, and they managed to write, they managed to write other programs with return statements as well. Now, why is it important to study computer science? Let me just look. This was an exam question I gave them. Year 7 children said, "Oh goody, I like essays." They wrote A4 size essays. And we'll just look at something written by Teresa, age 12. And she writes here, in a very animated fashion, about the future. And she writes, "The technological advances of the modern age have been spectacular, from simple things like Apple Watches to the more advanced artificial intelligence robots. With these changes comes a great responsibility for us as the future generation to create this science so that we can continue to innovate and create." And right at the end she writes, "The future is us, the young people. We can make a difference. The future starts now." So Teresa is speaking in an animated fashion, age 12, about the future. And here we have Boris, age 12, and he writes, "Nearly all the most famous and successful billionaires have made their fortune from making programs, which have become used everywhere, and so we now too have a chance to become as rich and successful as them." So that's precocious, motivated, ambitious Boris. So, somebody said, reading this, the problem is that the ambitions, aspirations and visions of these space-age young students far outweighs and outstrips those of their career pundits. That's Lilian Nandi, that's my father. He always wanted to speak his mind. The children aged 12 are being pointed to by these types of articles which appear regularly in our newspapers. Artificial intelligence in medicine. Their parents point them out to them. I know because I've spoken to their parents. And just to end here, inferences from the study. Now, we've only spoken about year 7 students, but those aged 12 found it easier than those 13, found it easier than 14, found it easier than 15. So starting properly from the beginning, I think, is maybe a message we should consider. 2, points need to be explained properly. We need to take our time to explain things to them, over and over again, if necessary. Students are happier with the teacher-led approach rather than the student-led or independent learning at this early stage. And many a parent has mentioned that to me as well. Terminology should be introduced along the way and pegged onto examples and operational definitions. There's a crying need for decent textbooks and resources fit for purpose, and the best students are the ones that are motivated to do well in the subject. So the why and the sales and marketing aspect is just as important. They were shown lots of videos of Elon Musk and Steve Jobs along the way. So we don't have much time, and come and talk to me afterwards if you like. But this is Plato here. We conclude by Plato, and this is just saying that we should consider everything in proportion here about children's choices. So thank you very much for your time. You can look at my YouTube channel, Lil Anonymous. That's my email there, demo999@yahoo.com. Thank you.
Thanks very much. We've got time for one question, if there is one on the floor. No? Yes? Yeah, go for it.
You mentioned the definite for loop as a terminology. What do you mean by a definite for loop as opposed to a normal for loop?
Definite iterative statement as opposed to indefinite iterative statement. For loops versus while loops.
Okay, so it naturally terminates after a while.
Sorry?
So it naturally terminates after a while. Rather than
Yes.
I understand.
Yeah.
Another question, really? No?
Yes.
Yeah.
I just asked, Therese, I've referred to Apple Watch as a simple thing.
Yes.
Do you think they've got unrealistic expectations about what they can achieve?
No, I don't. I think they can achieve a lot. I think they've got the right idea about what they can achieve. The head of Google started life in he didn't see, his childhood was spent in a 2-bedroom flat, sharing a room with his brother. I think, if anything, their expectations are high. If anything, the expectations generally are too low, and I think the adult expectations are too low.
Thank you once again for the very inspirational.